1990, over the Mojave Desert. Windows rattled, no plane was seen. No one has ever confirmed what caused it. Since then, similar booms have rattled the American Southwest for decades. Radar has caught fragments. Seismographs have logged the shock. But no aircraft has ever been photographed causing them. Lockheed Martin says it is building a jet that flies 6 times the speed of sound. They call it the SR-72 Darkstar. It has never been photographed. It may never officially exist at all. This is not a story about a plane. It is a story about an engine problem nobody has publicly solved, and about why the United States might want you to keep wondering if it is real. To understand the Darkstar, you first have to understand the aircraft it replaces. The SR-71 Blackbird, first flown in 1964, still the fastest air-breathing manned aircraft ever built. It cruised at Mach 3.2, above 85,000 feet, outrunning every missile fired at it. It flew so fast, the airframe itself leaked fuel on the ground and only sealed once, heated by friction in the air. Titanium skin, engines that breathed differently at speed than at rest, a machine built around a single brutal contradiction. That contradiction is the whole story. An engine has to work at 0 miles an hour and at Mach 3. The Blackbird solved it with a strange hybrid turbojet, one that behaved almost like a ramjet at cruise speed. It was retired in 1998. Satellites and drones had made it officially unnecessary. But satellites follow predictable orbits. Drones move slowly. Neither can look at a target twice in 1 hour from 2 angles on demand. That gap never closed. It just went quiet. In 2013, Lockheed Martin did something unusual. It talked. Skunkworks executives described a hypersonic successor to the Blackbird, a jet that could reach Mach 6. 6 times the speed of sound, over 4,500 miles an hour, New York to London in under an hour. They gave it a name, SR-72, a callback to the SR-71 plus 1, as if it were simply the next model year. Then, largely, they went quiet again. No test flight has ever been confirmed. No photograph has ever been verified. Officially, the program's status is unconfirmed, which raises the actual engineering question. Can anyone build an engine that does this at all? Here is the wall every hypersonic engine hits. A jet engine needs air moving slowly through its compressor blades to work. Below roughly Mach 3, that is fine. Above Mach 3, air moving into the intake is already hotter and faster than the blades can survive. A ramjet solves that by having no moving compressor at all. It just rams air in and burns it. But a ramjet cannot start from a standstill. It needs to already be moving fast, usually above Mach 2, before it can even ignite. So you have 2 engines, one that works from 0 to Mach 3, one that only works above Mach 2. There is no engine that does both. This is the problem Lockheed says it solved. They call it a combined cycle engine. One engine housing that operates as a turbine at low speed, then switches modes and operates as a scramjet at high speed. A scramjet is a ramjet's more violent cousin. Air moves through it faster than the speed of sound, even while combustion happens. Imagine lighting a match in a hurricane and having it stay lit. That is what a scramjet does, every second, at Mach 6. The switch between modes has to happen automatically, in flight, without stalling either engine. That handoff is the hardest 90 seconds in modern aerospace engineering. Get it wrong, and the engine flames out. So does this engine exist? Follow the paper trail, not the rumors. Aerojet Rocketdyne has patented combined cycle engine designs. So has Lockheed. The filings are public, the hardware is not. In 2018, Lockheed test pilot Rob Weiss said an SR-72 demonstrator, roughly the size of an F-22, had flown. No footage, no radar confirmation, just a statement from a man whose job was, in part, to manage public perception. Lockheed later walked the statement back. Officially, there is no confirmed demonstrator. Unofficially, the phrase itself was strange to retract. Why would a company deny progress on a weapon it wants adversaries to fear, unless the ambiguity itself is doing work that a confirmed photograph never could? This is where Groom Lake enters the story. Most people know it by a different name, Area 51, a facility whose existence the government did not officially confirm until 2013. The U-2 was tested there in secret, so was the SR-71. So, reportedly, was the F-117 stealth fighter. Every one of those aircraft flew for years before the public ever saw a real photograph. The pattern is consistent. Sonic booms first, patents years later. Public confirmation only once the aircraft is already obsolete. If that pattern is holding again now, the Darkstar could already be flying, and we would not know for another decade. Let's set the speculation aside and look at what building this machine actually demands. At Mach 6, air friction alone heats the aircraft's skin past 2,000 degrees Fahrenheit. That is hot enough to soften titanium, hot enough to melt most steel alloys outright. Which means the airframe likely needs ceramic matrix composites, materials normally reserved for rocket nose cones and re-entry vehicles. The Blackbird solved its heat problem with titanium mined, quietly, from the Soviet Union during the Cold War. The Darkstar's material problem is worse, and the supply chain to solve it barely existed a decade ago. Then there is fuel. At those temperatures, jet fuel itself starts to break down chemically before it even reaches the engine. Lockheed's answer, according to filed patents, is using the fuel itself as a coolant before combustion. The fuel absorbs the heat meant to destroy the airframe. It is an elegant trick, turning the enemy, heat, into the coolant that keeps the engine alive. But it also means every fuel line becomes a structural and thermal system, not just plumbing. Every gram of that complexity has to survive repeated flights, not just one trip to space. This is why so many hypersonic programs before this one quietly failed. NASA's X-43 flew for less than 12 seconds under scramjet power in 2004. That flight still counted as historic. 12 seconds. That is the entire confirmed public record of sustained scramjet flight in an American test program of that size. The Boeing X-51 Waverider extended that to over 200 seconds in 2013. Real progress, still nowhere near a usable engine. For the SR-72 to work as described, its engine has to run not for minutes, but for the length of an entire mission. That is not an incremental improvement over the X-51. That is a different category of engineering problem entirely, which is exactly why some engineers outside the program remain skeptical the SR-72, as marketed, is flying today at all. So why would Lockheed talk about a jet this far from finished? Because uncertainty is a weapon. If a rival air force does not know whether a Mach 6 reconnaissance jet exists, it has to plan as if it does. That means building radar systems rated for speeds that may not be real, spending on defenses against a threat that might still be paper. The Pentagon has a long history of using exactly this kind of ambiguity on purpose. The stealth fighter did it in the 1980s. Rumors of stealth technology circulated for nearly a decade before the F-117 was ever officially shown to the public. During that decade, the rumor alone changed how other air forces trained, spent, and planned. A weapon that might exist can do strategic work. A weapon that definitely exists cannot. This is the actual wedge in the SR-72 story, not whether the jet is real. The wedge is that the not knowing is the machine's actual function right now, whether or not a single airframe has ever left the ground. Every engineering choice we can verify, the fuel cooling, the ceramic composites, the dual-cycle engine, points toward a program still fighting basic physics. Every strategic signal, the leaked statements, the walked-back claims, the timed conference reveals, points toward a program that benefits from staying unresolved. Both of those things can be true about the same aircraft at the same time. The SR-71 flew for over 3 decades before its full story was ever told. If the SR-72 follows that pattern, the reveal is not close. It is decades out. So next time a sonic boom rattles a window in the Nevada desert and no one can explain it, remember, the silence afterward might not be an absence of an answer. It might be the answer. That is the machine Lockheed built, not just a jet, a question nobody can close. If you want the engineering broken down further, the next video covers the engine that might make this possible. Subscribe, and we will see you there. Consider what Lockheed actually confirmed versus what it let the public assume. Confirmed, a demonstrator existed. Assumed, everything else, including the shape on every fan render online. That gap between confirmation and image is not an accident. It is a program management tool used deliberately since the Blackbird era. Let adversaries argue amongst themselves about whether the capability is real. Every meeting spent debating a rumor is a meeting not spent building a countermeasure. That is the real payload of a program like Darkstar, not the airframe. The doubt it installs in a rival's planning cycle. Compare that to a fielded weapon like the F-35. Everyone knows exactly what it does. The deterrence comes from certainty. Darkstar, if it flies, works by the opposite logic. The deterrence comes from not knowing where the line is. That is a strange kind of weapon, one whose entire value depends on staying a rumor for as long as possible. Eventually, though, every Lockheed secret surfaces. The U-2 did. The Blackbird did. The F-117 did. Decades after it started flying missions nobody admitted to. So the question is not whether we eventually see Darkstar clearly, it is what state of the world we are in when that happens. By the time the U-2 was declassified, satellites had already replaced it. By the time the Blackbird was retired, its job had moved to space. Every Lockheed secret has followed the same arc. Reveal comes only after the capability has already been surpassed by the next one. If that pattern holds, whatever we eventually see labeled Darkstar will not be the frontier anymore. It will be the last generation's answer, made public once it is safe to. Which means somewhere past Mach 6, past scramjet, past everything we have discussed, there is already a program even further from daylight. That is the honest version of this story. Not a jet unveiled at an air show. A machine defined entirely by what it forces other nations to assume. And that assumption changes behavior right now, today, whether or not a single prototype has ever left a runway. That is the paradox we opened with. The most advanced aircraft Lockheed may have ever built might be doing its job perfectly by never being seen at all. An engine nobody photographs. An airframe nobody confirms. A shape that exists only as an outline behind a curtain and a budget line item that never quite closes. Lockheed has built exactly this kind of machine before, more than once, and every time, the world eventually caught up to what it was staring at. The only real difference this time is speed. Mach 6 does not leave much room for anyone to catch up gradually. So the next time someone tells you the SR-72 does not exist, remember what that sentence is actually built on. An absence of evidence, engineered on purpose. And the next time you see a grainy photo, a leaked patent, a strange contrail nobody can explain, ask the only question that actually matters here. Not, is it real? Ask what it is already doing to the decisions being made on the other side of the world, right now, in rooms we will never see inside. If this kind of engineering story is the one you come here for, subscribe and tell us in the comments which program we should put under the light next.